Hello, everyone, and welcome to Tier 1 Interventions Podcast, where we talk about strengthening your core classroom, that is, and specifically your core math classroom with academic and non-academic interventions. I am Jonily Zupancic, your host for today. We are bringing you a series of 3 podcasts in 3 parts outlining the 3 math rules that never expire. The 3 math rules that never expire. There was an article published in 2014. I'll show you the article in just a moment if you're watching this on the YouTube podcast where you can see my screen, but I will be talking through the creators of the article and some of the contents as well, so it will be very audio friendly. In this article, the article was titled 13 Rules That Expire. The article outlines 13 math rules that expire as we move into higher level mathematics or into secondary mathematics. Some of the rules are things like when you divide, a number gets smaller. That's not always true. When you subtract, we get the result of a smaller number. That's not always true. So the expiration on these rules, and really these rules are sort of unwritten rules. They are created by the language that we use in schools and classrooms. They are created based on the knowledge that teachers have or an attempt that we as educators have to make math simpler. We are very guilty of creating mathematics that is less simple by extracting out all of the complexities. And therefore, we create gaps, deficits, and misconceptions in student understanding because of what we think is this simplification process. Our goal should be to keep math complex, rigorous, and maximize the amount of access that kids have to complex, rigorous mathematics. Kids know when mathematics is complex and rigorous versus easy and simple. And oftentimes our most struggling students even struggle to do the easy and simple. So it's a really negative emotion that results when we are giving our lowest level students the most easy numbers and examples because we want them to be successful. So it's this counterintuitive idea. When we give our most struggling students the easiest or simplest of examples, they know it's the easiest and simplest. They still struggle. So that really deters their mindset and their motivation and their perseverance. It really negates everything that we're trying to create in our Matheneers. Matheneers are kids who can think, reason, problem solve. Matheneers have a very flexible and creative habit of mind when working mathematics. Matheneers are creative. So when we talk about these math rules that expire, we are just simply trying to simplify the mathematics that we're giving students. But in turn, in later years, students now have been ingrained with these deficits and gaps and misconceptions that we have to try to now reverse. So I'm going to bring to you in these 3 podcast episodes the 3 math rules that never expire. And to give credit where credit is due, we will take a look at the article. And if you're listening to this on audio only, the article is titled 13 Rules That Expire. And we must give credit to Karp, Bush, and Doherty. I hope I'm pronouncing that all correctly. Because this article has inspired so much math conversation and transformations in instructional practices because us as educators are a product of our system. We only know what has been done to us, and we only know how to teach, how we've been taught to teach, or what has been taught to us. So oftentimes we don't have the full exposure of the content that we need to deliver to students. The 3 math rules that never expire. Number 1, division is counting. So that is a statement that we can make and that we can use that will create a progression of division from preschool through high school. And yes, I say preschool because division should not be the quote unquote last operation we teach. It should be the first. I'll explain in a moment. And division is most accessible, especially for our preschoolers. And I'll share why that is in just a moment. But rule number 1 that never expires, division is counting. Rule number 2 that never expires, subtraction is distance. Yes, subtraction is also takeaway. Subtraction is many things that we can conceptualize. But the statement, subtraction is distance, is universal, it's transferable. And again, we can use this as a progression from preschool through high school, no matter the ability level of the student, the grade level of the student, and no matter the types of numbers we're using to subtract. And this is what makes these 3 rules so important because it is transferable. The strategy is transferable. The statement is transferable. The concept is transferable to all numbers, not just whole numbers. And the third math rule that never expires is that multiplication is rectangle. So the 3 math rules that never expire: division is counting, subtraction is distance, multiplication is rectangle. And in this 3-part podcast series, we will map out the progressions and cycles of each one of those rules and how they apply to all ability levels and all grade levels from preschool through high school. If we really want to shift mathematical practices to create and maximize understanding and learning for students, if we want to scale math achievement, because let's face it, in the US, our math scores are dismal and they continue to be dismal. They continue to drop or stay stagnant. So what's insanity? Insanity, doing the same thing over and over and expecting different results. Insanity is also trying to find the right program or the right textbook. To be honest, all programs, textbooks, worksheets, resources, all of them will work. And the strategy and the instructional delivery process that I'm going to share with you for these 3 math rules that never expire can be used with any resource that you're currently using as well. So these 3 math rules that never expire, we will outline the first one in this podcast: division is counting. Division is counting, and division is skip counting, and division is also sharing. So how does division apply to preschool? If you've ever met a toddler or a preschool age child, they can teach you a lot about sharing and sharing equally. So you may be thinking, you know what, Jonily, division really doesn't start until grade 3 standards. Conceptually, kids can't grasp division. Division is the last operation that we should teach of the 4: addition, subtraction, multiplication, division. All of that is untrue. Kids can absolutely grasp division, and they can grasp it better than subtraction oftentimes because division is counting, skip counting, and sharing. So if you take a look behind me, I've got what I love here. Oh, I'm going to get rid of that bag. What I love back here behind me on the top shelf math, by the way. And if you can't see this, I have 2 sides of a shelving unit. The middle is going to be the equal sign. So I want both of these sides to be equal. On the left side, I have 4 dice, each of the 4 dice showing 6. And on the right side, I have 4 brown lunch bags. I love this sensory material. I love this visual material. We call it brown bags and dice because it can represent visually division or equation or variable or whatever we want it to represent. But as we're talking about division today, this can represent division because on one side, I have the number 24. I have 4 6s, 24. And on the other side, I have 4 brown lunch bags that we don't know what is in each one, but we do know that each brown lunch bag has to have the same value, the same amount in each one. So as we're sharing 24 things, kids are very motivated, especially young students, as we're sharing. They're very motivated and persistent about equal sharing to make sure that everybody gets the same amount. So we have 4 people, we have you and 3 friends, 4 people total, 24 things, whether they're cookies or toys or pieces of gum, whatever it is. And the way that kids solve is by counting. And they may need 24 individual items, and they can skip count by ones and put an item in each bag. So kids can act out this situation of sharing. So in the earlier grades, we want to do a lot of sharing. We don't have to call it division. We don't use the division symbol. We don't need to make a big deal of it. And we also don't need to push mastery. These exposures with things like brown bags and dice will create the foundation that kids need for division. However, in the primary grades, I can teach my standards, which are basically simple counting and grouping objects and putting the same amount in each bag, or counting by ones, or counting by twos, or counting backwards from 24. So we need to really think creatively and instructionally about how we can use a strategy, a method, and a task that is, and I keep using this word, transferable to any number and to all grades. And we can maintain rigor and complexity and not strip the complexity out of the mathematics. What I'm going to show you now is a series of division cycles. This note page is called Intro to Division, Cycles for Grades, and I put grades 2 through 10. This is really appropriate, as I've just talked about, if we use visuals and one-to-one counting manipulatives for kindergarten and first grade. But I want to show you this division cycle, which explains division is counting. And this is the same process no matter what numbers you use. I just did this division cycle with 5th grade, 6th grade, and 3rd grade in the last couple of weeks. Oh, and by the way, you can get this bundle of PDF division cycles. So what you're seeing, if you can see this on our YouTube podcast, is cycle A with 4 different division problems. And it's very important that we go in this type of order with each type of problem. And it's also very important that the number selection is deliberate and intentional. And I'm going to explain the number selection as we go through cycle A. You can get the bundle of each of dozens of these cycles in a PDF form that can be your facilitation guide that you can use with students. Also in this bundle will be audio recordings of me, yours truly, Jay-Z, teaching kids in multiple grade levels this division cycle at different levels. So to hear me facilitate this with kids of different grade levels and to get the cycle, you will want to get the Intro to Division bundle, and you will receive the PDF resource of dozens of cycles, as well as the audio recordings of me facilitating this with students. When I explain it to you, it's a very different flavor as adults than when I facilitate and teach to students. So we're going to walk through cycle A, and then for you all to receive additional cycles as well as the audio recordings, we will make that accessible for you. Cycle A. The four problems are 6 divided by 2, 6 divided by a half, 231 divided by 7, and 2.5 divided by 0.5. And this cycle, these cycles say grades 2 through 10, and that is accurate. You could also use a part of this or a structure of this in K1, but you can use this exactly how I'm presenting it now in grades 2 through 10, because that is exactly the grade levels that I teach and that I work with and that I have actually done with these age levels of students. So first, 6 divided by 2. 6 divided by 2 in the most simple form, and especially with kids in grades 3 through 10, they're going to be like, oh, 6 divided by 2 is 3. Fantastic. No issues with that. But we're using this example to create a mindset and a conceptual understanding of division is counting. Remember, rule number 1, math rule number 1 that never expires, division is counting. So when I have a problem like this, 2, the second number, is my counting number. It is my skip counting number. So essentially what this division problem says is I need to skip count by 2s, skip counting by 2s. And if you are listening to this podcast, obviously you can get the information from the audio. But if you join us on Tier 1 Interventions podcast on YouTube, you'll be able to see the note taking. And I'm just writing a bunch of 2s, skip count by 2s, 2, 4, 6, 8, 10. Kids have access to skip counting by 2s. That's not a problem. As a matter of fact, 6-year-olds have a knack for skip counting by 2s. So division being counting, the second number is my skip counting number, 2s, and I can use dice numbers. I can use manipulatives. I can make this even more sensory. Skip counting by 2s. When do I stop? How do I know when to stop if I'm skip counting by 2s when I have the problem 6 divided by 2? Well, division is defined such that the second number is my skip counting number, and I'm skip counting to land on the first number, which in this case is 6. So I didn't need all 5 of these 2s, because when I skip count by 2s, I get to 6 after 3 skip counts. Hence, 6 divided by 2 is 3. Now, the next problem we want to do right away after this very simple 6 divided by 2, just to show the strategy, the procedure, the process. So in 6 divided by 1/2, 1/2 is my second number. It is my skip counting number. So I'm going to skip count by 1/2. For our older students, this isn't too much of a problem, and it's actually a very good exercise. Skip counting by 1/2, 1/2, 2/2, 3/2, 4/2, 5/2, 6/2. And kids may not know the meaning of that. So I may have to back up, and I'm holding up this paper strip. I may have to give kids another sensory material, a manipulative, my favorite are paper strips, have them fold the paper touching end to end, crease in the middle, open it up so that there are 2 parts, and talk about the value of each part being 1/2. Then I can use paper strips to show that on 1 paper strip, I have 2 halves. On 2 paper strips, I have 4 halves. So this rote counting can be the first step to creating a conceptual understanding of the value of 1/2 and the meaning of 1/2. So there may need to be some other, and you'll hear this in the grade 3 audio when I actually teach this to students. These students didn't really have a concept of 1/2. So we then did a little paper folding, and we didn't go on to the next division example because I wanted them to understand what skip counting by 1/2 looks like and is. Because once we can master that, then we can start skip counting by many other fractions and then start doing lots of division of fractions problem without the typical traditional division procedure of flip and multiply. Obviously, I would not ever do that in a 3rd grade classroom, but skip counting by 1/2 I would do in a 3rd grade classroom and beyond. The best part about these transferable cycles of division and stating that division is counting, the best part about this conceptual process is the progression from preschool through high school. And once we use this progression in middle school and high school, our kids that have struggled for years start to gain a new and aha understanding of division that they've never seen before because they've never done division this way before. I say this because as educators, as teachers, as parents, as intervention specialists, principals, curriculum directors, and coaches, we ourselves as adults may not have ever thought of division this way before. And therefore, we have not been able to implement this instructional facilitation method with our students. When we know more, we do more. This is ultimately how we're going to scale math achievement. This is one of the ways. So we skip count by 1/2, and how do we know when to stop? Well, the first number is 6, so we skip count by 1/2 to get to 6. And what I can do visually with that paper strip is I can draw a bar model, I can draw paper strips on a paper, and I can coach and explicitly teach students how to do this, how to create the bar model from their tangible hands-on paper strip, how to show that each bar has 2 parts. So I'm explicitly teaching this procedure of using the manipulative, yes, but they are conceptually developing their understanding of how many times we have to skip count by 1/2 to get to 6. So as the picture begins to develop, how many times we skip count by 1/2 to get to 6, if you can see my visual, I have 4 bar models all split in half. And as you can see, skip counting by 1/2 8 times gets us to 4. So I have to skip count a little more times to get to 6. And so 6 divided by 1/2 means skip count by 1/2 until you land on 6. How many times do I have to skip count by 1/2? It's going to take 12 skip counts by 1/2 to land on 6. So therefore, 6 divided by 1/2 is 12. The next problem in the cycle is extremely important. And this one is going to cause a lot of controversy. The problem is 231 divided by 7. Again, 7 is our second number. Our skip counting number is 7, 7, 7, 7, 7, 7. Oh my goodness, Jonily, why would I ever have kids skip count by 7s to land on 231? That is not efficient. Absolutely true. I'm not trying to build efficiency at this point. At this basic level, I'm trying to conceptualize division. And all I want kids to realize right now is, oh my gosh, it's going to take a whole lot of 7s to get to 231. That's it, especially younger kids. And then with my younger kids, I just want to leave that hanging. I just want them to understand that 231 divided by 7 means I have to skip count by 7s to land on 231. Holy cow, we're not going to do that today. Let's move on and just leave that go. One of the reasons that we let math linger is it continues to spin in the brain's subconscious. This is important for lasting memory for students. On some of our other podcasts, we talk about this. I'm not going to go into detail now, but this is a great place to just let math linger. However, with older students, and when I come back to this, because every lingering math problem I will come back to, not the next day, I need to leave space between the interactions for full access of long-term memory. So when I come back to this problem, maybe 2 weeks later or a month later, I might say, you know what, instead of skip counting by sevens, what other number is maybe an easier number to skip count by? Now, kids are going to say tens. Okay, so let's actually kind of combine tens and sevens for a somewhat efficient skip counting number. And I want to lead kids to 70 because 70 is 10 sevens. So I can chunk count 10 sevens at a time. Now, I'm not going to continue that thought because this is just intro to this division statement. But the last one I'm going to point out is 2.5 divided by 0.5. With my third graders, we've been doing a lot of talk of money this year and how money is written in decimal form as dollars. So they know that 2.5 could be $2.50 and that 0.5 is 50 cents. Now, if 0.5 is our second number in this division problem, 2.5 divided by 0.5, then 0.5 is my skip counting number. 0.5, 0.5, that's my skip counting number. And my goal is to land on 2.5. So kids can rote skip count. They can also conceptualize this. Okay, I'm skip counting by 50 cents. So we could even have fake or real money coins that kids can hands-on touch and do this. We're skip counting by 50 cents to land on or to get to $2.50. Friends, I present to you cycle A for our introduction to division. Following up this part 1 series, 3 math rules that never expire. Of course, based on the article that was released in 2014 by Karp, Bush, and Doherty, I hope I'm pronouncing that correctly. That article published in 2014 called 13 Rules That Expire, and they are 13 math rules that expire. What we are doing with 3 math rules that never expire are creating more solutions to negate those rules that don't expire and use rules that never expire progressively from preschool through high school. This has been Tier 1 Interventions Podcast with your host, JZ, Jonily Zupancic, in part 1 of the 3 math rules that never expire, focusing on division is counting.